Thank you. I would like to talk about own CLI tools in Go. It's on Go conference. It's on the Go conference. So I'm not a Go developer. I'm a DevOps guy. I run a DevOps company. I do DevOps trainings, mostly about Kubernetes. Go is part of the whole ecosystem, like the stuff between the Kubernetes and other stuff. It's the glue which puts all like DevOps components together. And we use Go only for some small tooling, some scripts, and I will be talking about those tools today. So why we want to create own CLI tool? We are lazy. We want to simplify some stuff. We are writing shell scripts since I think beginning of the Linux and basically beginning of the shell. So we are lazy. We want to automate stuff. So we are working with some scripts. As a DevOps guys, we don't write like the Go servers and backends. We basically do some automation scripts. So we have lots of use cases for it. Like we want to simplify some Kubernetes workflow. We want to generate some code. We want to bootstrap something. We want to onboard new developers, new engineers into the team. So it's lots of use cases for lots of small scripts. And we can write those scripts in shell. This is I think the basic and easiest way how to start with, but it's not a great idea after all, because the shell scripts, we will write the shell script once, we can run it forever. Shell works everywhere, that's fine, it's easy to write. Yeah, we can put all the tooling in one repository and that's fine. But is the shell really everywhere? Like we have Bash, we have Z shell, we have Windows, there's PowerShell, which is a super different shell. It's easy to write the shell script if there is like, I want to execute these 3 commands, that's it. If I want to do some more, if I want to integrate with some APIs, it's super hard to write complex shell scripts or bash scripts, whatever. If we want to distribute those scripts, in some cases we don't have internet access, we don't have Git, so we have to copy lots of files through some shared space in some shared disk, for example, for some air-gapped environment, for banks and government stuff. The internet connection is any connection to those systems. It's pretty hard. So yeah, we can use something else. We can use Python. Now on the Gophercamp, we will probably use Go anyway, but in lots of cases, sometimes we can use Python. Python solves one thing, and it's easier to work with than Bash. But if you want to run the Python, there is I think more trouble than with the shell itself. So it's lots of files. We have to distribute it. We have to use some virtual environments, and yeah. So another solution. I've prepared this super simple chart. We have this x-axis, easy to write the code. So Python is okay. If we want to easy to run, so if I want to run it, Bash is okay. If I use Perl, it's bad for writing, bad for executing, so skip that Perl. But we have Go, which is easier to run and very easy to write. So, okay, we will use Go. Why we want to use Go? This is great, even if you don't use Go in like your main language in your company, because something in this stack is like basically the best possible thing, and I think the Go is best tool for this kind of task, even if you have like Python or JavaScript stack. Go produces statically linked binaries, so we don't have any dependencies to our executable. We will build basically one binary which doesn't need anything else. It's easy to write the Go, especially even if you are familiar with Python or JavaScript, it's not that hard to learn the basic stuff in Go for this tooling. There's also great distribution because around the Go, there's lots of toolings like GoReleaser, which can build binaries for all the platforms. You can prepare integration with Brew, with Winget, so you can download the tools using the standard tooling, like install the tool on the Mac using Brew. On Windows, there's a native package manager as well, so that's kind of cool. And there's lots of libraries we can use in Go. So there's Cobra library, which is used in Kubernetes, kubectl, for example. So the stack and the ecosystem is great for this kind of tooling. So static living binaries, the output of our tool is one single executable. It's not a dynamic executable, so no linked libraries, which is great for portability. So if I want to run my tool on some restricted environment with some air-gapped environment, I would just move just one single binary and it works. I have to match the platform and the architecture, but in general it works, which is super useful. We have all the scripts in one tool, which is this SLU, shortcut for SikaLabs utils. And I know I have this version of SLU. I have all my tools there, so that's really useful. I will just build the binary statically. I'm not sure if it's by default statically linked in Go. I think from Go 21, the static link is by default, but this CGO enabled to 0 will force the static link binary. And it works on every platform. So my tooling works as well on Linux as well on Macs or Windows, which is quite useful. Another important part of this is GoReleaser. Have you used GoReleaser? Just one? Okay. GoReleaser is a super nice tool which can build the binaries for all the platforms. You want to define the platforms. Then it uploads those binaries to GitHub or GitLab and creates a configuration for Homebrew, create configuration for Scoop, for Winget. So it's super easy to distribute applications with the GoReleaser through your company or even worldwide. So if I use GoReleaser, I will build all the binaries for all the platforms, and then I can use Brew on Mac to install my application on Mac. There's no simple package manager on Linux, so I will use this install script and pipe into shell, which is not ideal, but it works. And I can also use a Windows package manager, which is Winget. It's kind of new if I compare the Winget with the apt or Yum repositories or with the Homebrew on Mac. So Windows have also native package manager, and you can also create a configuration for that, so you can install your binaries from native package manager on Windows as well. There's a Scoop, which is alternative to Winget. It's older one, but it's not official, but it works as well. So another great things in the CLI tooling is the Cobra and Viper libraries. It's used in, I think, most of the modern CLI tools in Go ecosystem. I can mention Docker, Kubernetes, Argo CD, Helm. Basically, everyone uses this library to make a CLI interface. HashiCorp has own things, so yeah, Terraform is something different, but basically all the other common tools use this Cobra library. It's super easy to use. It great autocomplete, so I can very easily put my autocomplete for my tool into bash rc, zshell rc, whatever. It works also with Windows, which is great. And I can generate documentation to GitHub, like it generates some markdowns, and I'll have some documentation for my tool as well. The Viper library is for the configuration, so if I need to read some configuration files, read some environment variables, I can use Viper for that, and it's from same author as the Cobra library. This is the example of the autocomplete. So basically, I have a completion subcommand in my tool. I choose the platform, bash zshell, PowerShell, and put it into my bash rc or source it at first. So I have a autocomplete from scratch. That's I think very useful as well. This is the example of the generated documentation. It's super simple page. I think it's okay. It's not like it's basically the markdown version of help in command line. I don't really use this as much because I have the help in the command line. So I think I generate this by some GitHub action, but I'm looking basically only on the CLI help. And we have a couple of tools. I mentioned the SLU, which is lots of SikaLabs internal toolings. We have all the things on GitHub. We have training CLI, which is my set of scripts for my trainings, and other tools. We have some backup tool, which is backup tool. It's not a CLI tool as well. So, but it uses the same stack, the Cobra and the Go Revisor stuff, and the cycle is very similar. So we have the SLU here. Some examples of the SLU is we want to get a certificate from some endpoint. So I have a command for that. I want to generate some random logs if I test, for example, Loki or Elasticstack, command for that. We want to generate keys for WireGuard. Yeah, I will generate all the keys in one place. I don't want to generate private, then from the private create a public and so on. So it saves some time. So another example, I have this training CLI. I can set up some Kubernetes cluster for my trainees, and then just call from the test containers or test machines, connect the cluster. It will connect the cluster. Very similar functionality we have in some onboarding tools. If I want to put the configuration for the Kubernetes, for example, for all the developers, we have something similar there as well. And I want to show you a live demo. So we will create super simple CLI tool. So let's try it. So okay. So I've created a simple repository. I have a simple repository here. There's nothing a part of this README. And because we create lots of this simple CLI tools, we have also a shortcut for that. So SLU file templates and Go CLI project. So this is super simple bootstrap, the basic structure of the project, and then we will work on from this bootstrap as well. So I'll copy this. Basically, this is the name of the project, package, and some configuration. Where is the brew repository? Where is the Docker repository? I want to push Docker images there. So let's run this. And it generates some code. We have a Go mod. We have just the Cobra dependencies here. We have a main Go. And here we have a root command of the commands section here. So here we have all the commands. We have the root command. There is our go helper camp, basically the command we want to run at first. There is no functionality yet, and we have a one subcommand version. So this prints version which is stored here in this file version. We have also a Go releaser here. So this is the configuration for the Go releaser. We want to build for these platforms. We want to ignore some legacy stuff. We want to put the archive of the build binaries onto GitHub. And here we have a configuration for Homebrew. So there is a repository Ondřej Šika /homebrew tab on GitHub. So if I publish this build, the release of this project, I will also create a configuration here in the tab repository, and I will be able to install the binary from the brew. There is also how to build a Docker images. If I want to distribute my tool in Docker, there is a way how to distribute the thing in Docker, and that's basically it. So I can try to build this and run it. Go build. Go get. Go mod tidy. Go build. And it created a hello Gophercamp, which is super simple CLI tool. You can see the version here. You can see the available commands. I can run a help, which is same because I don't have any functionality there. There is a completion. I don't have the completion yet. So if I will copy this completion bash, and if I use this one, I can source it, and because I don't have it here, I can do, I think I have to build it, deploy it, and then I will show you the completion. I'm not sure if this works. So yeah, I will show you the completion later. So that's it. We want to put something there, so I can create a subcommand. So here I can copy, for example, this version. I will create a hello command, make hello here. It will be hello, and the name of the command, hello. Short name will be hello Gophercamp, for example. We can have a alias for it, so I can use just h. And in this run, there is a function which we run. So here I can put a hello Gophercamp, no version, we don't need the version here, and that's it. So super simple stuff, and I have to import this this package here into this CMD. So I will import it here as hello, for example. And now if I build it, go build hello Gophercamp. Now you can see there is a hello. You can use hello, cool. I can also create a run function here, so I can also put the run into root command if I don't want to run hello there. I can use something like this here. So if I build it again, I can also run the command here and get the help with just -h. So yeah, super similar. And I want to release it and publish it. So I will commit it, git add, git commit, and Okay. I can tag it, so git tag version 1. And now I can run the Go releaser. If I show you the configuration for the Go releaser, we will run some hooks before, so I will push all the stuff to GitHub, then I will build it, and so I just run Go releaser. There is also a Go releaser GitHub action, so you can run it in GitHub or GitLab CI. I don't have a GitHub token, which is required because I will publish the binaries into GitHub releases. So I have to source my GitHub token, and I will now run a Go releaser. And you can see we are building all the binaries. We are creating the archives. We are building a Docker images, and we will push the Docker. We will then upload the archives, and that's it. So yeah, releasing, and okay, it's released. So I can open the GitHub repository with it, and you can see there is a release. You can see all the binaries here, and if I open my GitHub, there is a tab. So if I open this tab repository, there is a Hello Gophercamp RB, which is the configuration for Homebrew. I've created this right now, and now if I want to install this on my computer, I can go here, and I can go to home, whatever, brew. Okay, brew install, I will remove the test. I've tested it before, so I want to install from my tab, my tool, Hello Gophercamp. So I'll do that. I hope it will work. It has to update the repository, but yeah, seems to be okay. And yeah, now we are downloading the tool, and Hello Gopher. I think I have to source the. Oh, I will open the new terminal. It will be easier. Hello Gophercamp. It works. -h. Yeah, perfect. So this is the super simple way how to build some CLI tooling in Go. The distribution is super elegant, and yeah, I think it's a great replacement of all the legacy shell scripts and manual stuff. We used to have lots of like shell scripts, Python scripts as well. These days we use ChatGPT to basically transform those scripts into Go. It's super easy. We fix a couple of small things, but the porting the shell into Go is pretty okay with the AI. So we basically move everything into just one SLU in one Go tool, and it's really really great. So the yeah, summary. We figure out the CLI tools in Go are like super useful. It's easy to run, easy to distribute, easy to develop. So yeah, that's our outcome. Thank you for your patience, and if you have any questions, just ask.
See that you are going a little bit in interface for command line, like user interface library from the Go?
Yeah, we never tried something like that. We really like K9s for Kubernetes, the terminal UI. I think they use some kind of library for that, but we didn't use anything like that, so I don't have any idea.
They exist.
Yeah, I think they exist. The K9s is, I think, the no, I can show you. This one is written in Go. It's a Kubernetes CLI UI, CLI dashboard. I think there is some library for that. It's pretty useful, but we have no experience with building own tool like this, so they exist. Okay, any other question? Okay, thank you, and I'll be there so we can chat a bit, so thank you as well.